This video, we're going to determine whether a graph is a function, and if it is, we're going to determine its domain and range from the graph. We're going to find any intercepts from the graph if we can. Those would be x-intercepts and y-intercepts, and any symmetry that it may have with respect to the x-axis, y-axis, and or origin. So let's go ahead and let's look at this first graph. I'm going to go ahead and zoom in here so we can examine it a little bit more closely. We're going to see that this is not a function. Because it does not pass the vertical line test. We see that for the same x value, we get more than one y value at, say, x equals -8. There is where I drew that line, I believe. 3, 4, 1, 2, 3, 4, 5. X equals -6. There we go. Okay, so at x equals -6, we have a y value of, it looks like +4, and a y value it looks like of -4. So not a function. Let's just go ahead and let's talk about the intercepts while we're here. There are no y-intercepts because it doesn't cross the y-axis at all. There's x-intercepts at -3, 0, and at +3, 0. It is symmetric to the y-axis. If I put a mirror on the y-axis, the reflection of this piece on the right would look like the piece on the left, and vice versa, because every point over here, x, y, has a corresponding point over here, -x, y. That's what y-axis symmetry is. It looks like it also has origin symmetry because it looks like every point x, y also reflects to a point -x, -y. And it looks like it also has x-axis symmetry because every point x, y looks like it reflects to a point x, -y. So it looks like it has all three kinds of symmetry. It's not a function, so I'm not going to talk about its domain and range. Let's move on to the next graph here. This is a function. It's going to pass the vertical line test. You can't tell very well, but this is approaching this vertical asymptote here. It's a function that's getting closer. As I zoom in there, let me clear the drawing and see if I can zoom in here so you can see that a little bit better. That it's called asymptotic behavior. There's a vertical asymptote at x equals 0 there. So there's probably not a horizontal asymptote over here. This is probably based off of a logarithmic graph. I can't tell for sure, but it looks like it. So I'm going to say that yes, it's a function. And I'm going to say that its domain is that x is greater than or equal to 0. And it looks like its range is that y can be anywhere between -infinity and infinity. Let's go ahead and let's write those instead in interval notation like we're used to. So let's write that as greater than or equal to 0 is like that for the domain, and the range is -infinity to infinity. It looks like it possibly has an x-intercept at 1, 0. And there's going to be no y-intercept because x equals 0 is a vertical asymptote, and there doesn't appear to be any symmetry to this graph. All right, let's look at the next one here. This passes the vertical line test. Yes, it is a function. It's got x-intercepts at negative pi, 0, 0, 0, and pi, 0. It's got a y-intercept at 0, 0. It looks like it has origin symmetry. Because it looks like every point that's up here, that's xy, reflects to a point down here that's negative x, negative y. It does not fold across the y-axis because it's not in quadrant 2. Over here, it does not fold across the x-axis because it's not down here in quadrant 4. So to go from quadrant 1 over here to quadrant 3 is going to require a reflection across the origin. This quadratic function is a function. Yes, it has x-intercepts at, looks like negative 4, 0, and at 2, 0. And it looks like it has a y-intercept possibly at not 0, 9. And it's symmetric about its axis of symmetry, where the vertex is up there at negative 1, 0, or I'm sorry, negative 1, 10. It's symmetric about this line x equals negative 1, but that's not my x-axis or my y-axis or my origin. So there's no special kind of symmetry here. The circle of radius 5 right here is not a function. It's centered at the origin there. So it's symmetric about the x-axis, y-axis, and origin, all three. It's got x-intercepts at negative 5, 0, and 5, 0. And it's got y-intercepts at 0, negative 5, and 0, 5. This is a piecewise defined function. We'll talk about them a little bit more later. But we can see that the graph does two different things, that it's got a linear piece and then a quadratic piece that are connected together. It passes the vertical line test. Every vertical line that goes through from left to right is going to touch the graph only one time. So yes, and its domain is going to be from -2 included to infinity not included. And its range is going to be from 0 included as the lower bound if I'm going from bottom to top, all the way up to positive infinity. And let's see here. I guess I can talk about domain and range of these things over here, even though they're relations. This goes from -5 to 5. And this also goes from -5 to 5. Let's see here. And this one, I didn't answer about domain and range. That one goes from -pi to pi. My range is from -1 to 1. And I got domain and range there. My domain here is negative infinity to -3 union 3 to infinity. And my range here is going to be negative infinity to infinity. All right. Let's see if there's any types of symmetry up here. No, no symmetry. And this one, you got to be careful because there's a dot over top of a dot. It's not going to pass the vertical line test right there on that X value because there's going to be two Y values for the same X value. So it's not a function. It would be if one of those closed circles had been open instead, so that there was only one value for Y for that X value. It looks like there is X-axis symmetry here. No, there's no X-axis symmetry, excuse me. Apologize, because it doesn't come over here on this side, it's over on the other side, so there's no symmetry. And my domain is all real numbers, and my range is just the set -7 and 7. It can only be those two numbers, one or the other. And that's going to be it for right now. We're going to come back and we're going to evaluate some graphs and determine some things about them in our next video. All right, see you next time.